Okay, AP Stat babies, let's talk about this idea of simple events versus compound events. What does this mean, Ms. Griggs? Well, a simple event implies that we are dealing with one outcome, all right? So again, what would that look like? Well, the best way to describe one outcome to you is to just give you some examples, because basically it just means that we have a simple or single event. So some examples of simple probabilities. The probability of rolling a 3 if I roll a 6-sided die. All right? There's only one way that can happen. All right? There's only one way I can do that. If I roll one die, there's only one event that can occur. That's a simple probability. What is that probability? Well, if it's a 6-sided die, the probability is 1 out of 6. That's pretty easy to understand. Another example, the probability of drawing an ace of hearts from a deck of 52 cards. Well, there's only one ace of hearts, so this is just 1 out of 52. All right, so there's another simple event or single event. So think about another one. The probability of getting heads when I flip a coin. Well, the probability of doing that is 1 out of 2 because there are 2 possible outcomes, and the probability of just getting heads is just 1 out of 2. So I want you to notice that for a simple event, your numerator is always 1 because it's a single event, one outcome. All right, so when I'm dealing with compound events, you guessed it, this means that there is more than one outcome. Okay, so more than one outcome when I'm dealing with compound events. So what would an example of this look like? Well, let's take this into consideration. The probability I will roll an even number less than 5 on a 6-sided die. Well, think about it. These are all the possibilities of all the numbers I can get when I roll a die. Well, if I know it's even, that leaves those. And if I know it's less than 5, that takes out 6. So the probability of this happening would be 2 out of 6. Again, more than one outcome is possible. I could land on a 2, so I could roll a 2, or I could roll a 4. The reason I'm not saying roll a 2 and a 4 is because I can't roll both of them at the same time. All right, so the probability I roll a 2 is 1 out of 6, or the probability I roll a 4 is 1 out of 6. So or implies addition. So that's how I get the probability of 2 over 6, because I can roll 1, I can roll a 2, or I can roll a 4. All right, now the or rule about both doesn't apply to this, because if I roll a die, I can't have 2 outcomes, okay? So the idea of one or the other or both in this case does not work, because these events are not independent of one another. They're mutually exclusive or disjoint because they can't occur together. So here's an exception to that or rule. We'll get more into or later, so don't get upset yet. Okay, so now I'm going to think about the idea of the probability of drawing a red ace from a deck of cards. So from a deck of 52 cards. Okay, well, if you know anything about cards, you know that there are two red aces. There's a red heart, ace, and there's a diamond ace. Those are both the red cards, all right? So there are two possibilities. I can get this one, or I can get this one. So I'm going to have 1 out of 52 and 1 out of 1 out of 52. So I'm going to have 2 over 52 total. All right, so that's what that would look like. So the probability of drawing a red ace from a deck of cards. Well, it could happen in one of two ways. It could happen this way, or it could happen this way. So that's 2 out of 52. All right, let's look at another example of a compound event. The probability of rolling an even number on a die, then tossing a head on a coin. Okay, so I'm going to roll the die. So I'm going to think of the probability of getting an even number on the die. Well, half of the numbers are even, so that's 3 out of 6. Then tossing a head on a coin. So I'm tossing a coin and I land on heads. These events are completely independent of one another. One doesn't have anything to do with the other. That means I can get an even number on my die and I can get a head on my coin. So that's 1 of 2. And since my probability is one and the other, this gets multiplied. So I've got 3 out of 12 for my probability. Do you see the difference between or and? Because these two things can happen at the same exact time. They're independent of one another. Whereas these two things cannot happen at the same time because of the way the question is worded. All right, and same thing up here with the die. All right, let's look at another one. Combination events tend to be, they show up more. That's why I'm doing more examples of these. So let's say the probability, you're going to love this one. It's going to be your favorite. The probability of drawing a heart, replacing the card. So this is with replacement. Replacing the card, then drawing a spade. Okay. Because I'm replacing the card, these events are independent of one another. If I left the heart out, it would change the probability for drawing a spade. But since I'm replacing it, these events are independent. So the probability of drawing a heart, well, 13 of the cards in a deck of 52 are hearts. So if I do this, if I get this, this is this probability, and then, okay, I'm replacing the card, and then I'm drawing a spade. This probability is also 13 out of 52. So this total probability is 169 out of 2,704. That's what that probability is. Yes, it can get ugly.